Okay, thank you. Good morning. Today I will talk about the work WireDraw, 3D wire sculpturing guided with mixed reality. And 3D wire sculpture is the creation of sculpture out of wires. And traditionally, the artists usually use metal wires, and which requires professional skills for deforming and assembling. And the availability of 3D extruder pen allows for direct drawing of 3D wire sculptures, which is much easier for novice users. But the most common way is still drawing in the 2D plane and then assembling them together. The mobile fabrication provides 2D guidance, and user could draw 2D objects on the mobile screens. And for 3D, there are many customized 3D printers to create 3D wire models, but they all focus on triangle or quadrangle wireframe, which consists of short straight lines. So what if we want to draw freeform 3D wire models directly? It is much harder than 2D drawing. And for example, this is target model we want to draw, and good drawing results should be like this one, but what you usually get are those ones with huge distortion. It is hard to control the shape of the curves, and such as the length, angle, and drawing context. For example, if the user is asked to draw a line vertically, it's probably not vertical at all from the side view. And there are several typical drawing results from the pilot study. The challenges of 3D drawing can easily lead to wrong topology and inaccurate length and wrong scales. And it may lead to unbalance, such as the tiny circular base in this case, and shape distortion. So we need to provide a good guidance to help users to draw 3D strokes. And there are already many research papers on drawing 3D virtual strokes, but not so many on drawing real 3D strokes. And for guidance, there are different methods such as projecting the guidance on the surfaces and showing shadows on screen. But in our case, there is no such kind of surface for projecting the wireframe, and shadow is not accurate enough to guide wire drawing. A common way to help users draw 2D sketch is to trace the underlying sketch template, which is also used to teach drawing to children. It is similar with the shadow-guided method, but provide more accurate sketch guidance. So, could we generalize this idea to 3D drawing and make the 3D drawing easier? Mixed reality could provide a spatial context for interaction. So we could project the 3D wire template into the spatial context, and then we could do 3D tracing just like the 2D. So we create such a system called WireDraw, and we allow users to trace the 3D virtual strokes to draw high-quality real 3D wireframe easily. But we could not just project the entire wireframe to the spatial context, since most wireframe cannot be drawn in only one stroke. And the order of strokes is really important for 3D drawing. So it is really different from 2D. So we need to decompose the wireframe into a collection of strokes and determine the sequence. Hence, the basic part of the WireDraw is stroke generation. And to be more specific, we consider the following three problems: stroke decomposition, stroke sequence, and the view direction of each stroke. There works generating strokes from 2D curves or 3D surfaces for metalware sculpture, but all strokes are planar in their case. And they did not consider the sequence and the view direction, so it is not enough for our freeform-ware decomposition. And to decompose the 3D ware model, we apply 3 principles. First, low complexity. The number of strokes should be as small as possible. And second, smoothness. As a smooth stroke is easier to draw and the sharp turn is really hard for the 3D extruder pen. And last but not least, planarity. As drawing one stroke in a plane is easier even in 3D. In 2D drawing, we could draw in any sequence, but in 3D, sequence is really important. So there are 3 problems required to be considered. First, dependency. Physical drawing in 3D requires that each stroke must depend on other strokes or the spot plane, such as a desktop. And second, closeness. We prefer drawing continuously instead of moving our pen all around the world. And finally, 3D curves may occlude our hand and the pen. For instance, as shown here, if we draw the black strokes first, it is hard to draw the blue one. And for to solve the occlusion problem, changing the viewing direction is also a reasonable way. And besides, appropriate view direction could provide more accurate information for user, and the user could ensure that the curve is drawn accurately. Those principles mentioned above may contradict with each other, so we cannot optimize them individually. And so we put them into one optimization, and we use simulated annealing with 4 operators: the joint and the split for stroke decomposition, and swap for the sequence, and casting for choosing the best view direction for each curve. And this video shows an example of the optimization. The color shows the stroke sequence starting from the blue to red. Based on the optimized strokes, we can guide users via mixed reality to help them draw 3D-ware objects. And we add 2 web cameras onto the Oculus to convert this VR device to MR device. So we could see the real world through the cameras. And we also provide a sliding track that allows users to adjust the pupil distance. And to provide drawing guidance, we also need to track the pen and analyze the relationship between pen and the virtual ware object. So we use markers to track the pen nib and show the virtual ware model. By default, all the virtual objects will be rendered above the real objects, which leads to depth ambiguity. And hence, we take advantage of the pen tracking to render a transparent virtual pen to provide the correct depth relationship between the pen and the ware model. For user tracing the virtual strokes, the strokes are shown one by one with animation. And we also render a reference model on the corner to show the entire model and highlight which part has been drawn to avoid getting lost during the drawing. The highlighted part of the wheel ring shows the optimized view direction that is optimized by our algorithm. To provide more accurate feedback, we show 3 states to tell the user the relationship between pen nib and strokes. If the pen nib touches the endpoint of current stroke, the stroke and the ball on the pen become green. If the pen moves along current strokes, the color turns blue. And if the pen is far away from current stroke, the color is red. Besides, to avoid the virtual stroke interfering with the real strokes that has been drawn, we set the drawn parts of the strokes to be transparent. Here is an example to show the drawing process. User could trace the virtual strokes in MR environment, and the top left window shows what the user sees in Oculus. Besides, to enhance the user's creativity during the drawing, we allow users to edit the input wire model on the fly. And the user could select strokes by pen and delete them. Then user can draw some new curves and undo if not satisfied. And the stroke sequence will be updated automatically in real time. And here is an example to show the creativity of user. The user can edit the existing model easily and then draw the real wire model guided by WireDraw. Now I will show some results and the evaluation. These are the input wire models, and they optimize the sequence. And these are the drawing results guided by WireDraw. Obviously, the results are better than what we see in the beginning. And for comparison, we asked 10 users to draw 3D wire objects in 3 scenarios: free drawing, sequence on display, and guided by WireDraw. And we show 3 examples here. For free drawing, the user has no guidance, except that they are allowed to rotate and scale the virtual wireframe on a monitor for observation while drawing. And for sequence on display, the use of additionally provided our optimized drawing sequence shown on a monitor. And for sequence on WireDraw, the user is fully guided with the drawing sequence, occlusion hint, and viewing direction hint, and so on the display of Oculus. And to evaluate the effect of the optimized sequence and IMAR guidance, we asked 27 persons to rate the drawing quality of drawing results from the 10 users. And the bar chart shows the mean score of these 3 scenarios, and the higher is better. And we can see that our system definitely improves the drawing result. The reason is that in free drawing, in order to find which parts should be drawn next, users always spend a lot of time observing the model and making decisions. However, users may not always find the best drawing sequence or even get lost. And the bad sequence will cause difficulty or even fail the drawing. With the optimized sequence, users could avoid failure and problems caused by bad sequence, but stroke shape is still hard to control. And with the guidance of WireDraw, the quality is much better since it is much easier to control the stroke shape. And finally, for the people who are good at drawing, they could draw 3D wire models without huge distortion after practice. But their free drawing results may be unbalanced due to the inaccurate stroke shapes. And drawing with WireDraw could overcome this problem. And future work. First, we could extend our work to guide users to draw surface-based models. And second, the drawing speed of 3D extruder pen also affects the drawing process. And drawing too fast or too slow will cause distortion of the strokes. So we could also provide speed guidance. And finally, we could provide more flexible on-the-fly editing, such as deformation. Okay, thank you so much for listening.
Hello, I'm Zhang from Purdue University. Very interesting work. So I have one question about the user's input. So right now you are using an optimization algorithms to generate the sequence of strokes, right? So I assume it's a deterministic result. That means there's only one optimal solution. So how about, how do you think if there's a user input, user's preference there?
Oh, thank you. For the optimization, there are 6 terms to let users to adjust to control the optimization process, and the user could define which part should be important than other part. So the optimization result is not the.
But user just, I mean, here just play some those weights, right?
Mm-hmm. Yeah.
I'm talking about some maybe user prefer to draw this portion first. Give some stroke as input or selection in your interface as input.
In our interface, user could select which strokes that they want to draw first. And the following sequence is generated by our algorithm.
So that means user can input some preference. Okay.
Yeah.
Thanks.
Hi, great work. Michelle Annett from Mishmash Makers. So I have 2 questions. Number 1, what is the latency of the system? And my second question is, in the videos, you showed that the user was holding something. It looked like they were holding something in their left hand. I was just wondering what that was.
Yes, because users need to control when to show next stroke. So in the video, you can see the user hold a controller, and press the controller. We will show the next stroke, and user could draw physical strokes following the virtual strokes.
And so what was the system latency?
Sorry?
Like, what was the system latency or the delay between what the videos was capturing and the tracking of the pen and what the user would actually see?
The optimization is pre-processing. So when user use this system for drawing, there is no latency problem. So, thank you.
Hi, great work. Just one quick question. What's the biggest shape you have ever drawn with your system?
The biggest one is some scale like this one. So
like with one stroke, or just like multiple strokes scalloped on each other, or just like one stroke?
We did not considering about the really large scale objects. So, but we could draw each part and then assembling them together.
All right, thanks.
Hi, I'm Olivia from UW. I just had a quick question if it was an active choice to use virtual reality instead of an augmented reality system, or if it was just the nature of the time and like not having access to like the HoloLens development kit or something?
Yes, we could use another platform, yeah. And the technique is similar and also based on the markers. So,
based on what? Sorry.
Yeah. Sorry?
I'll talk to you after, it's fine.
Oh, okay, sorry.
All right, this is the end of the session. Let's thank all of our speakers again.